Hello students, in this video I am going to explain different concepts available in Python. If you are new to the programming language or if you are new to the Python programming language, this video definitely help you to improve your programming skill. This video starts from how to install a Python compiler and how to write a simple programs, data types available in Python, condition statements and looping statements, and input-output statement, how to use these statements in your program, then how to add Python commands and working with strings and handling multiple data items using collections, and finally discussed with error handling. Let's start with the first concept called Python installation. Our first step will be setting up Python on your system. There are three ways to install the Python in your computer. First one is through Python installer. Second one is through Google Colab. Third one is through integrated development environment like PyCharm and Spider, etc. First we will see how to install Python from default installer. Here we have to download the Python executable file from the official website. Then install the software. Go to the google.com, type Python download, select the official website python.org, select downloads and click Windows. Here different versions of Python can be listed here. I can select Python 3.12.7 in 64-bit Windows installer. It starts to download, then you have to click to install it. I already installed this software, so I can open the Python compiler now. Once it installed, it comes in the program files installation path. So go to the softwares already installed in your system, Python. Here I installed two versions of Python. So one is 3.12 and click the IDLE. Click the file menu and new file. Here I want to print my country name. First I want to save this file, then run the file. So this is the first way we have to execute the Python program. Let's move to the next way of execution of Python using Colab. Colab is a short form of collaboratory. It's an environment that runs from cloud. We just type the program. The entire execution part can be taken care of the cloud. Here we have to go to this URL to run our Python program. Then create a new notebook. Go to the google.com again, type Google Colab, click this URL, create new notebook. Now new environment is created for executing our Python program. I try to execute one simple program here. So in this way you can get the output in the Google Colab. So this is the second way of execution of our program. Let's move to the third way of execution called some Python IDEs. So these are all some Python IDEs. Now I execute one Python program using PyCharm. I already installed PyCharm here. I just double click it. This kind of IDEs can be used only for creating some projects. But for this introduction purpose, we will see how to run simple program in this kind of IDE. Go to this project and select the new Python file. Give the name of this file. I can give 2 here. So 2.py Python file is created. I just type one Python command and run this code. So the output can be displayed here. So in this way also we can execute our Python program. So this Python default installation called Python IDLE, it is suitable for beginners. And these two best for creating projects. And comparing these two, PyCharm can be installed in a standalone system, whereas Colab can be installed in separate remote system called cloud. So whatever the resources we are including, that can be loaded in the cloud and that can be executed. But here, what are the resources needed to execute along with the project that can be loaded in the standalone system. If our system is a very good configuration, then we have to choose this kind of IDE. Otherwise, we can use the Colab. We just only have the very good internet connection, the resources that need to execute the big projects that can be taken care of the cloud. So in this video, we are executing our upcoming programs only through the Python IDLE only. And we should know one more thing about Python execution. Python can be executed in two modes. One is interactive mode, another one is script mode. In interactive mode, we can give the commands and get the input immediately. So in our operating system, we can open the terminal or command prompt and type Python. If you install the Python, the window can be looks like this. Now we can give the Python commands here. So we can get the output. So this is called interactive mode. And next one is script mode. In a script mode, we have to save our sequence of commands in a file. The file extension can be .py. Open the IDLE. I already created one file. Now I execute my program. I can get the output. So this is called script mode. So hereafter I can run all the example programs through the Python IDLE only with script mode. So the installation part is over. Let's we move to the next topic called simple programs. In this part, we will discuss how to write a simple program in Python. The first program we have to practice to print our name. I open the Python IDLE again. First create a new file because I am writing a program using the script mode. Using the print statement, I can print my name. That's all. We have to save this file in your computer. So you can select one particular location. For example, give some name and save it. The extension should be .py. Click the run button and run module. So you can get the output. So this is the first practice. We have to print any text. Next program is to print the integer number. I just go to the same program again. So I declare one variable a equal to 10 and print a. So don't forget to save the program before running. Then run the program. So I can get the value 10. Then the next program to print integer and string in same print statement. So here I want to give some meaningful information. A value is, then give comma, then the variable name. So I can mix the string constant as well as the variable. Now I want to execute this program. So I can get the meaningful result, that is a value is 10. So here I mix the integer and string value in a same print statement. The next program is to get the value from the keyboard and print the same value. So this program can improve your skill how to get the dynamic values from the keyboard during the program execution. So using the input statement, I can achieve this. Now the program is executing. It asks the value from the keyboard. I can type 12 here. The result is a value is 12. So I can get the value dynamically during the execution, the value given from the keyboard, and I print the same value. Next program is to find the addition of two numbers. So here I want to get the two values from the keyboard, then I want to add it and print the result. So this program can practice to you to get the input values from the keyboard as well as the processing and produce the output. So I can get the two values. These two values can be added. Then I want to print the result. So this is the actual coding. So I can get the two values from the keyboard, add these two values here. The result is stored in the variable C, then print the result. But this program will throw some error. It does not give the proper output. First we have to execute it, then I correct this program. So it asks the two input from keyboard. So first input is 10, second input is 5. but it produced the result 105. So actual expected result is 15, but it produced the result 105. That means it concatenate, that is 10 plus 5 105, instead of adding these two exact values. The reason is, what are the values can be accessed from the keyboard that can be treated as string. So we have to convert this string variable into integer variable. So I can introduce new variable called d equal to integer of a, then e equal to integer of b. Now a and b variables are string variable that are converted into equal integer variable. Now we have to add d plus e. The result is stored in C. Now we can get the expected result. So first value is 10, second value is 5, the result is 50. So everything we have to receive from the keyboard, that is treated as string. So we have to convert the appropriate data type, then we have to do the actual processing. I rewrite the program in another format. So instead of creating these two separate variables, I can use this integer method here. Now I no need to declare these two variables. So C is equal to A plus B. So the input function gives always string value only. That can be converted into integer. That value is stored in A. The same thing happened in B. So now A and B values are integer only. Now the actual value is added here. The result is displayed here. So I can give the first value and second value. The result is 50. So this is the right way to execute the program called addition of two numbers. The next program is find the square root of given integer number. So I can get the only one value from the input and I want to find the square root of the given value. So I can get the value from the keyboard using input function and integer method. Then I want to find the square root value. So sqrt is a default function that converts the given integer into the appropriate square root value. So that is stored in the variable b. So I can display the variable b here. So I can give the value as 25 and it produces some error message because square root is the function that can be present in the library file called math. So we have to include the necessary library file in the starting of the program. So I can try to include the appropriate library file that can be achieved by import math. Now I try to run the program. I can give the 25 value again. So the result is 5.0. I can execute the program with different value 100. The result is 10. The next program is to find the area of circle. So in this area of circle, we need a radius information, that is only one input. Now we no need for import function. So a equal to, you can give different variable name radius. So I can get the radius value here and I want to find the area of circle. So area of circle formula is pi r square. So 3.14 into r into r. I can give the value of the radius. Radius 2 centimeter. The result is 12.56. I try to run the different values. If the radius is 5, the result is 78.5. The next program is to find the total number of 6 subject marks and also find the average. So here, first we understand the number of inputs. We have to get the 6 inputs, that is 6 subject marks. Then we have to produce the 2 outputs. One is total, second one is average. So first I get the first mark here. So that is taken as M1. I just copy this line. So 6 marks can be collected from these 6 lines M2, M3, M4, M5 M6. So I can collect the 6 different integer variable. Then I want to find the total. The total values is equal to all the addition of these 6 subjects. And I also find the average value. So that can be calculated by total divided by 6. So I can give the appropriate message here. Total is and the average is average. So this is the actual result. I try to execute the program. So it has the 6 different marks. I can give the marks one by one: 25, 45, 88, 45, 34, and 89. So the total is 326 and the average is 54.33. The next program is to find the simple interest and compound interest. So in this kind of program, we should know the formula for finding this simple interest as well as compound interest. The simple interest and compound interest formulas are: the simple interest is PNR divided by 100, compound interest is P into 1 plus R by 100 whole power of n minus 1. We know how to process these different variables in a previous simple programs. Now I execute this program directly. So it has the p value, that is principal amount 5000, then n value is 2 and the r value is 18. So the simple interest is 1800 and the compound interest is 1861. The next program is to solve the quadratic equation. So these two programs are comes under the same category because we should know how to solve the quadratic equation manually. That means we know the formula for quadratic equation. So this is the formula for quadratic equation. So we have to produce two results and we have to analyze how many inputs are needed. So in this formula we easily understand there are three variables are needed. One is A, B and C. A is nothing but the x square coefficient, B is nothing but the x coefficient, C is nothing but a constant for this quadratic equation. So this is the actual code. So instead of typing, I just copy the code. So first I give the A value, that is x square coefficient value 6, x coefficient value 5 and the constant value is 1. So now the x1 value is minus 0.3, x2 value is 0.5. So in this way we have to write the simple programs to solve the particular problem using Python. So you can practice this program. It will help you to solve any problems given in your examination. So you can try it yourself using this program to solve two integer number, to find the area of triangle, to convert one format into another format, and to solve the quadratic equation in a different way. So up to this, we learned about how to write a simple programs using Python. The next topic is data types. In this part, I will explain what are the different data types available in Python. Data types are nothing but type of the data that helps to indicate how much of memory allocated in main memory. So the different data types occupy the different memory sizes. So the compiler needs to identify what kind of data can be used in our program. There are two categories of data type. One is basic data type, another one is other data types. These basic data types are frequently used in most of the programs. They are integers, floating point numbers, Boolean values, and collection of characters called strings. Along with data type, there is an inbuilt function called type. Using this inbuilt function, we can identify which data type we are using. I will explain the use of this type function when executing our example program. Let's see the overview of different data types. Numbers can be mentioned as either integer or floating point numbers or complex numbers. These values are comes under numeric data type, and collection of characters are represented as strings, and collection of different data types can be used through either list or tuple. These data types are comes under sequence data type, and some more collections are represented as either dictionary or set. The decision making variables true or false comes under the Boolean data type. Out of these data types, integer, floating point numbers, Boolean, and strings are treated as basic data type. Let's see one example program for data type. In this example, I can use three different variables. First one is integer, second one is floating point number, third one is complex number. In Python programming, we need not to declare explicitly the particular variable as belongs to particular data type. Depending upon the value assigned to that variable, the Python compiler treated as that particular data type. So we want to know the data type for the particular variable means by using type function, we can identify the data type of the particular variable. So I try to execute this program. So it shows the first variable, that is A is a integer data type, B is the floating point data type, and last one C is the complex number. And I want to include one more data type called Boolean data type. So that is D. Can type the Boolean variable that is either true or false. So I try to display the type of the variable D. So the expected answer is the variable D is the Boolean data type. When I run the program, it shows some error. It shows the line number 7 has some problem. But here there is no line number. Go to the option menu and click the show line numbers. So the seventh line is the problem. For this Boolean value, this true is not a correct keyword. So I can change the T as capital letter. Now this is the correct keyword for the Boolean variable. So I want to run the program now. Now it shows the correct answer. So the type of the variable D is Boolean variable. So this simple example is enough for understanding the basic data type. I will explain the other data types called strings or and some more collections in upcoming parts called working with strings and sequences. So the data type part is over. Next we discuss the different condition statements available in Python. In this condition statement part, we will see how the control flow can be done by the compiler. Control flow is nothing but execution order. Usually, execution can be done by serial manner, that is, one after another. We can do some decisions by means of some statement and make the change of this execution order. Such statements are called control statements. One of the control statement is conditional statements. Condition statements are change the control flow, that is execution order, depending upon the decision made. These are the example of conditional statement. If else, if elif else ladder, and nested if. Let's see one by one with example. In a simple if condition, the code after the if statement is executed only if the condition is true. Otherwise, this code cannot be executed. We can give small space after the if statement, then only this block is treated as if block. These are the some relational operators for making decisions. Let's try one program with simple if statement. This program helps you understand the meaning of simple if statement. I can give the value 40 to the variable called a. I can check the value whether it is greater than 50 or not. If the condition is true, this statement going to execute. Otherwise, no statement can be executed. There is no output for this program. But in this code, there is small mistake is there. After the if statement, there is a small space, that is indent is needed. Then only this print statement going to execute. I will try to execute this program with this error. It shows the error. So expected an indented block after if statement. So this compiler shows the error message like this. So I can give the intent by typing the tab key. So intent is given. I save the program and run it. There is no output because the 40 is less than 50. So this condition is false. So there is no statement is going to execute. Now I change the value 40 into 80 and try to execute the same program. Now it shows the output called pass mark. So this print statement is executed only if the condition is true. So this simple if statement can execute this particular statement or skip this statement depending upon the situation. So our execution order will be changed. That means control flow is changed. We can make the decisions using any one of these relational operators. Next one is if-else statement. In this statement, there is one condition is there. If the condition is true, the if block is executed. Otherwise, the else block is executed. I try to execute one program for this. So in this case, I can add the else part. I can write the else part here and not in this part and give the print statement. Now I execute this program. So this is pass mark only because the mark is 80. Now I change the mark into 30 and save the program and run it. Now the output is fail mark. So depending upon the condition, either if block statement is executed or else part statement is executed. We can carefully give the indent space between if and else part. If and else part comes under the same alignment. The particular block of statements can be identified by this indent space. So we can carefully give the indent space between these lines. The next statement is if, elif, else later. If you want to check the conditions continuously, then we can go to the if, elif, else later. That means sometimes we need to check more than one conditions in a single problem. In that case, simple if statement or if else statement cannot be adopted for this situation. So for the continuous condition checking, first if statement check the first condition, then else if, that is shortly called elif, check the second condition. So we can add so many elif statement to check more than one conditions, to check any number of conditions, and finally if all these conditions are not satisfied, the final else block code is executed. So note down the syntax for if, elif, else later statement. Let's see one example program. In this program, I am going to find the student grade from the student mark. I assume the student mark is 95 and I want to check the student mark is greater than 90 or the mark is in between 80 to 90 or 70 to 80, 60 to 70, 50 to 60. So depending upon the range, I can give the grade like this: A grade, B grade, C grade, D grade and E grade. And finally, if the mark is less than 40 means print the message like fail. So I need to check more than one condition in this situation. So I can use the if, elif, else statement. The conditions can be checked in so many steps. It looks like a ladder. That's why it's called if, elif, else ladder. When I try to execute this program, it can check in this first condition. This condition is true. So the first if block statement is executed. Then the program is going to end. I try to execute it. So the grade is A grade. I want to change the mark into 82 and save the program and run it. So now the grade is B grade. So the mark is in between 80 to 90. So the grade is B grade. I want to change the mark again. For example, 57. Save the program and run the program. I can get E grade. E grade is nothing but the value is in between 15 to 60. Suppose the value is less than 50 means, suppose the value is 44, it will show the output as fail because all these conditions are going to false. So finally else block is going to execute. So the message fail is shown as output. So whenever we want to make multiple decisions in a same program, we can use if, elif, else statement. The next one is nested if statement. Nested if is nothing but if statement within another if statement. In some cases, we can make the decisions within the another decision making statement. So the nested statement looks like this. This is the first if condition and corresponding else part is there. Within if block, I can use the another if condition. This is the condition 2. This condition 2 has its own else part. If this condition false, this else block is going to execute. If this condition is false, the first if else part is going to execute. Let's we see one simple example. In this program, I have two data about the student. One is age, another one is mark. If age is greater than 18 as well as mark is greater than 90, then I can announce that student is eligible for attending the particular course. Otherwise, I can give the appropriate error message. So first I check the age is greater than 18 or not. If it is true, I can check the mark. If both are true, this statement is going to execute. Otherwise, if the first condition is true and second condition is false means this else part is going to execute. That means age is okay but mark is low. Suppose age is less than 18 means this condition becomes false. So this else part is going to execute. So age is not okay. So it gives the error message like this. Suppose the mark is 95 means the output is eligible because both the conditions are true. Suppose age is less than 18 means age is not okay. So we need not to check the mark value. So in this way we can use the nested if statement. So up to this condition statement part is over. Next one is looping statements. In this looping statement part, we will see how the statements are repeated number of times. By using looping statements, we are able to repeat a code or group of code at a finite number of times. There are two types of loops in Python, for loop and while loop. And along with this, nested loops are there, that is nested for loop and nested while loops. In this Python programming, there is no do while loop. This is the syntax for loop. For is the keyword, in is the keyword, and sequence is the collection of items. After this line, we can give the indent space so that to identify the for loop block of code. Sequence is nothing but one kind of data type having collection of items. We will see deeply about this collection in this part. In this example, the collection of items are created by list. It has three colors as string values. We can iterate that colors one by using this for loop. I is the variable we are created. Colors is the collection of item, that is list, which contains three colors. The total number of item is 3, so the for loop is iterated 3 times. For each iteration, these values are printed one by one. I execute this program now. It shows the color one by one present in this list. So when we read collection of items one by one and manipulate it, we can use the for loop in this manner. For loop can also used with range function. Using range function, we can iterate the code any number of times. This is the syntax for the for loop with range function. This range function returns the sequence of numbers. We have to mention the starting point and end point of the number, and we can mention the increment order. If we are not mentioning the starting point, it treats the 0 as default value. If we are not mentioning the incremental step, it treats 1 is the default value. So these two values are optional, but we should mention the end part, that is how many times it will be repeated. In this example, we can start to print the number from 1 to 10 with the increment of 2. I execute this program. It starts with 1 and incremented up to 10. Suppose if I want to print the numbers from 1 to 10, the increment value becomes 1. Now the expected answer is 1 to 10, but it produces 1 to 9 only. Because Python works on zero-based indexing. That is, the default starting point is 0 and ends with n minus 1 number of times. Here, the n value is 10, so up to 9 only this statement is iterated. If I want to print 1 to 10 means I can give the value as 11 here. So now I can get the value 1 to 10. So instead of collection of items, we can use the range function and repeat the statements n number of times. We can fix the starting point, end point, and number of steps incremented by each point. The next looping statement is called while loop. Here while is the keyword and we have to mention one test condition. If the while block is repeated as long the condition is true. In this example, the condition is I less than 10. If the condition is true, this block is going to execute. So it prints the I value, then it increment the value. This condition is again checked. If the condition is again true means these statements again executed. Otherwise the control is transferred out of the while loop. Let's check one example program. Here I value is 1, so this condition is true, so this statement is going to execute. So 1 is printed first, then I value is incremented into 2, the condition is checked second time, this time also the condition is true, so the 2 value is printed here. In this way, the while block is repeated 10 number of times. At one stage, I value becomes 10. So 10 less than 10 condition is false. In this stage, the program comes to end. So I can print the value from 1 to 9. Suppose I want to print the value 1 to 10 means I can change the conditional operator like this. So I less than equal to 10. Now try to run this program. So I can get the value 1 to 10. So instead of for loop, we can also use the while loop by making the statements repeatedly executing. In a for loop, we are using the range function to specify the starting point, end point, as well as incremental value. These three components are mentioned in different places. Now you can try with some simple programs by both for loop as well as while loop. You try it yourself. And the last topic in looping concept is nested loops. Nested loop is nothing but a loop within another loop. We can create a nested loops for both for and while statements. This is the structure of nested for loop. First I create a first loop that is called outer loop using the range function. This is a first range function. Inside this for block, I can create another for loop that is the second loop called inner loop. It contains another range of values. So the inner loop and outer loop of statements can be executed that many number of times specified in this particular range values. In this program, I try to explain one simple nested for loop. This is the outer loop, contains the range value starting from 1. It's repeated 5 times, that is I value is 5, and the incremental value is 1. Up to 5 times this loop is executed. In this inner loop, it is iterated up to j times, that is 10 times. The increment value also 1. I want to make a pattern using this symbol called star. So 5 into 10, 50 number of times this statement is going to execute. So the star can be displayed like this. But I want to print this star in horizontal manner. So I can use one concept called end parameter. Now I try to execute this program. Now the symbol is printed in a horizontal manner. The reason is when I am not giving this value, your Python compiler automatically added the new line at the end of every printf statement. To avoid this, we can give this kind of blank spaces using this end parameter. Suppose I want to print the inner loop only in a particular horizontal order means I can insert the necessary new line to the appropriate place. So in this intent, I can give the print new line. Now I try to execute this program. So for the first iteration, it shows the 10 stars in a single row. Then new line is executed. Then in a second iteration, another 10 stars can be displayed. In this way, 5 rows can be created. So we can modify our output as per our requirement depending upon the n parameter as well as new line. So we should know how to use this n parameter as well as the new line in an appropriate place to make our desired output. So up to this, looping statement part is over. Next concept is input and output functions. In this part, we will see what are the input-output functions available in Python and how to use it. These input and output functions allow a program to be a dynamic because they enable interaction between the program and the user, making the program adaptable to different situations or data. So, for every execution, we can get different input and produce appropriate different outputs. The input function in Python is used to get the data from the user as a string. Whatever the data we entered, that is taken only as a string value. Even though you type an integer value or floating point value, it is also treated as string value. Before executing an example program, let's look at the syntax of the input function. The input function in a Python is used to get the data from the user as a string value. The input function in a Python is used to get the data from the user as a string. Whatever the data we entered, that is taken only as a string value. Even though you type an integer value or floating point value, it is also treated as string value. Before see one programming example, let's look at the syntax of the input function. Here, input is the keyword. Within bracket, we can give some message about the expected input. Once we call the input function, it returns the string value that can be received by one variable. The data type of this variable always a string. Let's check one example program. In this example program, I try to get one integer value using input function. And I try to run this program. I can get enter integer value. I can type the integer value 5. So the result 5 is produced. In this example program, I try to get our country name. The name is always stored as string value. I try to execute this program. I can get the output. Suppose I try to get the integer value. So I type here country name as well as one integer value, so I can get both the results. So in this way we can get any data type value using the input function. We already seen all the values written from the input function only in a string data type. Let's we check with the example program. So I can get two integer number and I try to add these two number and try to print the result. First I type the value as 10. Second integer is 20. The expected result is 20 plus 10 is 30, but I can get 1020. So it's clearly known that the value written by the input function only is a string. So here A and B values are string variables only. So these values are not added. Actually it is concatenated. First string value is 10, second string value is 20. Both are concatenated and produce this result. If you want to get the integer number means we have to convert that string value into the integer number. So I can call the integer function here. So I can convert this string value into integer number. So I can make the a and b variable as integer variable. Now these actual values are added and stored in the variable c. Now I can get the actual addition. So first value is 10, second value is 20. Now the result is 30. In a output operation, print is a function used to display output to the output device, particularly to our computer monitor. We can give a direct message or show the content through the variable. Let's look at an example. Here I can display a direct message. In a next line, I can use a one variable having some value. Using the print function, I can try to print that value. So I can get both the results. The next part we should study about the formatted output. Formatted output allows you to control how the values are displayed in a specific format. This is useful for displaying data in a structured and readable way. In this example, the first variable called name is string variable having the value Jenny. The second variable called age is integer variable having the value 40. I want to display these two values in a proper structured way. So I can use either format specifier method or I can use necessary curly braces to get the desired formatted output. Let's execute this program. In this example program, I try to display name and age without formatting. So it just simply print name and age. Now I want to get this output in a meaningful way. So I can use any one of these methods. In this first method, I can fix this variable inside this string using the format specifier, that is %s for string, %d for integer. So I can adapt these two variables in appropriate order. So the name is assigned in this position and age is assigned in this position. In the same way, the formatted output can also achieved by using this method. Within these braces, I can insert the appropriate variable name. So when we are executing this program, these two values are inserted in this proper order. Let's execute this program. So I can get the output in a meaningful way. So in this way, you can get the formatted output. Up to this, input output functions are over. Next topic is commands in Python. In this part, we will learn how to add simple nodes to our code called commands. When a programmer includes necessary commands, others can easily understand the meaning of the code. In large projects, commands make the code more manageable and easier to maintain. What are the text typed inside the commands that can be ignored by the compiler? There are two types of commands, single line commands and multi-line commands. Single line commands are created using hash symbol, whereas multi-line commands can be created using triple quotes. Use single line commands for short specific notes or inline explanation. Use multiple commands for detailed descriptions, especially for function classes and complex logics. This is the syntax for single line and multi-line commands. This program will explain single line as well as multi-line commands. The first line started with the hash symbol indicates this is a single line command. In between the triple quotes, all these lines are treated as multi-line commands. These two parts cannot be executed by the compiler. The first printf statement and the second printf statement only executed. So when I execute the program, only the two print statement can be executed. When we compare the C programming commands as well as Python command, in C programming, single line commands can be achieved by double slash, whereas in Python, hash symbol can be used. In multi-line commands can be achieved by slash asterisk symbol and asterisk symbol slash. Within these two, we can write any number of lines. In the same way, within triple quotes, we can create any number of multi-line commands. Let's see another example program. This program for finding factorial number for given integer value. When we add necessary commands, now the code become more readability and easily maintained by others. All these commands are single line commands only. Depending upon the necessity, we can add multiple commands also. In your examination, you can add necessary commands in appropriate places. It will give more perfection on your program. I hope you understand about the commands and how to use it. The next part of our video is working with string using Python. In this part, we will see how to handle strings using Python. String is a sequence of characters enclosed within single quotes, double quotes, or triple quotes. Strings are used to represent the text data. It is a built-in data type in Python. Let's see one example program. In this example, I created three different strings using single quote, double quotes and triple quotes. When I tried to execute this program, I got the output like this. When we want to get multiple line string output, then we have to use triple quotes. Otherwise, we can use either single quotes or double quotes. We know string is the sequence of characters. So we can loop that each characters one by one and do some string operations. This is the syntax for using string with for loop. Using this for loop, we can read each characters one by one for the given string. Here, x is the variable, banana is the given string. When we loop this collection of characters, we can get the result like this. Using this feature, we can achieve some string operations. For example, suppose we want to find the particular characters present or not for a given string, we can use this method. I explain this operation in the next program. In this program, I am going to count number of character A present in the given string. I can get the string dynamically from the keyboard and initialize the variable count equal to 0. I try to loop this code up to total number of characters present in the string. When I iterate the string characters using the for loop like this, we can read the characters one by one. For each iteration, we can check whether the current variable is equal to the character A. If the condition is true, I can increase the count. Otherwise, this statement cannot be executed. After all the iterations, I can print the count value. If the given string does not having the character A means the total count will be 0. Now I can execute this program. It asks to enter a string. I write India. So the total number of character A present in this string is 1. Suppose I can give the another value. So in this string A can be present 2 times. So the total count is 2. In this way we can achieve some string operations using this method. String operations are doing some manipulations on string. I listed very few operations here. String length is to find number of characters in a string. String concatenation is to combine one string to another. Can check whether the given two strings are equal or not. String slicing is to extract particular portion of a string. Let's see some examples one by one. In this program, we can find the number of characters present in the given string. In the first line, I can get the string value from the keyboard. Using the length function, I can find the number of characters that can be written as an integer value, store that integer value in the variable called length. Finally, I print the length value. I execute this program now. I enter the string India. So the total number of characters is 5. I enter this program again, give the value hello India. Now the total length is 12. This 12 can be calculated like this. This is the first character, second, third, fourth, fifth, sixth, seventh. Blank space also one of the character, 8th, 9th, 10, 11 and 12. So total number of characters are 12. In string concatenation, we can combine the second string at the end of the first string. In this program, I can create two strings. One is hello, second one is world. First I print these two strings separately. Then I want to concatenate these two strings. The resultant content is stored in the new string called S3. Then I print the string variable S3. So the first string is hello, second string is world. The combined word is called hello world. If I want to give the space means I can use this character like this. Now the space can be created. So using this plus operator, we can concatenate two strings. Concatenate means we can attach the second string at the end of the first string. The third operation is string comparison, in which we can compare two different strings, either they are same or not. So in this example, I created three different strings. One is hello world, second one is I love Python, third one is hello world. First I want to compare string 1 and string 2. These two strings are not equal. And in second, I can compare string 1 and string 3. These two strings are equal only. Let's see what happened when we execute this program. So I can get the Boolean variable called false. when these two strings are not equal. When the comparing strings are equal, then we can get the value true. So using this method, we can easily identify whether the given strings are equal or not. Let's see one application example. In this program, I want to check whether the entered string are present in the existing list. The different color values are stored in the list called color. I can read the color from the user and check whether the entered color is exist in this list or not. So using the for loop, I can iterate the each and every item one by one. For each iteration, I can check whether the entered string is equal to the any one of the content in this list. If these two strings are equal means we can get true. If it is true, the entered color exists in the list. Otherwise, the entered color not in this list. Let's check the code. I entered the color called blue. Blue color is already existed. So in the first iteration, the color is not in this list. But in the second iteration, the color blue is exist in the list. Suppose if I give the new color, for example, black. Black is not in this list. So after all iteration, it does not find the color called black. So in this way, we can check the particular string is present or not in a collection of values. Then the string slicing is a technique to extract the portion of the string. It allows you to specify a range of indices to extract characters. String slicing can be achieved by this syntax. Using the square bracket, we can mention the starting point of characters and how many characters from the starting point, and third parameter indicates whether we are increment one by one or any n value. So the given string is hello India. If you want to slice the string, 0 means this is the zeroth index. From the zeroth index, the third characters are H, E, L. We can traverse the characters one by one. This is the meaning for this one. So when I execute this program, I can get the result like this. H is the zeroth indexed element. From this zeroth index, three characters are H, E, L. This can be traversed by one. Suppose I want to mention instead of 1, I can type the value 2. Now I can get the result like this. So this is the zeroth index element. From the three characters, I can skip this element. So I can get H and L. Suppose I remove the value 0 and mentioned as 1. Now I can get the result HEL. That means the default value of the first position is 0. The index is start from the first value, that is H, and read the three characters HEL. Suppose I remove the third part, that is increment value. Now I can get the same result. So the default increment value is 1. If we miss these two values, our Python compiler automatically take 0 as the first value, 1 as the last value. If I want to display the hello, so the hello is the 6 characters, so I can give like this. So I can get the value hello. So it is better you can mention all these values. Suppose I want to remove the last two characters means I can give like this. So minus 2 means from the right to left, these two characters can be reduced, then remaining characters can be displayed as a string. So if you want to reduce the particular characters at the end and display the remaining strings means you can use this method. Suppose if you want to print all the characters means the total number of characters are 12. So I can give the value 12 here. Then I execute this program. So I can get the entire string value. Suppose I want to get the reverse string means I can give the value like this. These parameters give the reverse string value. So hello India can be reversed in this way. So using this slicing method, we can get the different substrings. That means we can extract the particular portion of the string. We already know about C programming language as so many library functions for strings. In the same way, Python also different library functions for string. These are the whole string functions available in Python. Check this document in the notes provided in the description link. You try to execute and practice more string functions. Up to this, we learned how the strings can be handled in the Python, and different string functions are available in Python library. The next topic is collections. In this collection part, we will learn how to handle multiple data items in the Python programs. Collection refers to any data structure that is designed to store and manage multiple elements. These elements could be numbers, strings, or any other type of data. We can broadly classify the collections into two categories based on whether we maintain the order of elements or not. The two categories are ordered and unordered collections. Ordered collections are called sequences because they maintain the order in which elements are added. Examples of ordered collections include list, tuples, and strings. This means that each element in these collections has a specific positions or index, and you can access elements using these indices. On the other hand, unordered collections do not maintain any specific order for their elements. Examples of unordered collections are sets and dictionaries, in which elements are stored without any particular sequences. So, depending on whether we need to maintain order or not, we can choose the appropriate type of collection. Sequences are a type of data structure used to store and manage collection of ordered elements. They allow you to access elements based on their position. Python supports several sequence types, including collection of characters called strings, collection of integers generated by a range function, collection of any data type inside list or tuple. We already discussed about handling the strings and range function in for loop. Let's see how to handle multiple items using list and tuple. Sequences are used to store data in containers, which allow easy indexing and slicing for accessing specific elements. It supports iteration to process each element in the sequence. Sequences maintain the order of elements, meaning you can access elements in the same sequence they were added. In the upcoming sections, we will discuss list and tuple in detail. Like an array concept in C language, list can store multiple values in single name, but it stores different data types in a same name. List can be created by square brackets. This is the syntax for creating list. We can give the list name equal to, using the square bracket, we can add the number of items. In this program, I can create one list called colors in which I can add 3 elements. When I run this program, I can get the result like this. So all the list elements can be listed here. These are the features of the list. We know these 2 points. List can store multiple items in a single variable. It may be a different data type. And third point is list is a mutable. Mutable means the elements present in the list can be changed after it is created. For mutable objects, you can modify their content. Example, add, remove or update the elements. The list elements may contain duplicate values. In a list, the position of each element is fixed, so it is an ordered collection. Once we create a list, it can be looks like this. The each position can be uniquely identified by the index number. From left to right, the index can be start from 0 to n-1 value. From right to left, the index value start from the -1 to -n value. Let's see one example program to illustrate this concept. So in this previous example, we can display all the elements. Now I want to display the particular elements of the list items. So now I try to display the red color only. I make this statement as comment. Now I can get the first value. So 0th index element is red. So the red is printed here. Suppose I want to display the second element means I can give the index as 1. So I can get the read the second element. Suppose I want to display the elements using the minus index. Minus values means so -1 is the last element. So it will display the color blue. So inside the list, we can read the particular elements using the index. These are the list related functions. Using this function, we can achieve the different operations on the list. Now I explain how to use this function. For example, append. Append means add the new element in the existing list. In this example program, initially the list colors having the three elements called red, green and blue. We can print the initial list values. Then I want to add the new color called pink using the append function. Then we can check whether this new element is added or not. So initial list contents are red, green and blue. Then after the append function, the new colors can be added at the end of the list. So in this way, you can use any of these functions in the list to achieve the required operations depending upon the problem statement. You can practice the remaining functions in the list. We can move to the next topic called tuple. Tuple also like a list, it stores multiple items in a single variable. It also contains different data types and it created by round brackets. So this is the syntax for creating tuple. We can give the tuple name. Within the round bracket, we can insert the items. So instead of square bracket, I can use the round brackets. So the colors is treated as tuple. Now I try to print the tuple items. So it can be printed like this. So I can get the output like this. Suppose I want to print the tuple elements one by one, then I can use the for loop. Now I can print the tuple elements one by one. Suppose I want to print the particular tuple elements means I can use the index. So in this way we can access the particular element from the tuple using the index like list. Suppose I want to display the last element of the tuple means I can use the negative index called -1. So it refers the last element of the list. So it displays the color blue. So in this way we can access any element from the tuple. These are the properties of tuples. The main difference between the tuple and list is tuple is immutable. That means once we created the tuple elements, we cannot modify. Tuple also allow the duplicate values and it is also a ordered collection. And these are all the tuple functions. So using these functions, we can achieve some operations. For example, count the particular elements present in the tuple or not and finding the number of elements present in the tuple and we can achieve the sorting operations and etc. So you can practice the programs with different functions available in tuple. So up to this we discussed about the sequence types called list and tuples. Let's be discussed about the next collection items called set and dictionary. So like list and tuple, set also store multiple data items in a single variable. It is also store the different data types and it is created by using curly braces. This is the syntax for creating set. So in this program, I can create a number of elements using curly braces. That means a set is created. The name of the set is called colors. So it can be printed like this. These are the properties of set. Like list, set is a mutable. That means after creating a set, we can modify the elements. But the set is differed from the list by means of set does not allow the duplicate values and it is unordered collection. So the ordered collections are list and tuples, unordered collections are set and dictionary. These are the different functions available in set. We know the set is a mutable, so we can add the new items and clear all the items and perform different operations available in these library functions. You can practice using these functions in a simple Python programs. Now I try to compare list, tuple and set. List can be created by square bracket, tuple can be created by round brackets, whereas set is created by curly braces. and list is mutable and set is also immutable. Tuple is immutable. List and tuple are ordered collection whereas set is unordered collection. List and tuple allow duplicate values whereas set does not support duplicate values. So after this set concept is over, now we will discuss about dictionary. Like list, tuple and set, dictionary is also used to store multiple data items. But the main difference is it stores the pair of value that is called key value pair. And dictionaries are unordered mutable data structure and it does not allow the duplicate values. Like set, dictionaries are also created using curly braces but with pair of items. This is the syntax for creating dictionary. In this example, I can create a dictionary called student in which it contains three elements, each element having pair of values. The first element is called key, the second element called value. So these two are collectively called key value pair. First I want to print all the dictionary elements. So all the key value pairs can be printed like this. Suppose I want to print the key values only means I can use student.keys. Now I can get the key values only, that is 1001, 1002, 1003. So these are all the register number and this is the student name. So now I want to print only the register numbers. Suppose I want to print the student name only means I can use the function called values. Now I can get the values only. So using this dictionary concept, we can solve the so many real-time problems. Let us consider your class having so many students with the register number and name. I want to give one register number whether that particular student is present or not. So I have collection of student list and I want to enter the particular student's register number. In this for loop, I can read all the key values one by one and check whether that register number is equal the entered register number or not. If it is there, I can tell the student is exist in this class. So it asks the student register number. So I can give 1003. So 1003 is the register number present in this dictionary. So after giving the enter key, so it shows the particular register number is present in this dictionary. So in this way, you can use the dictionary in different operations. So these are all the different functions available in the dictionary. You can practice these functions one by one. Now I compare all collections items. These two are ordered collection, these two are unordered collections. Each collection of items can be created by the different formats like square bracket, open bracket and curly braces with key pair values. And each collection is having mutable or immutable in nature. And some collections are allowing duplicate values and some collections are not allowing duplicate values. So depending upon the situation or depending upon the problem, we can select the particular collection and store the multiple data items to achieve the particular task. So up to this, we learned about how to handle the multiple collection of data and the last concept is called error handling. In this error handling part, we will learn how to handle errors or exceptions in the Python programs. Errors and exceptions are runtime issues that occur when a program encounters conditions it cannot handle, such as invalid user input, missing resources, or system limitations. These issues can disturb the program's normal flow and can force the program to terminate suddenly. Usually, a programmer can create a code that may work fine in his system, but when that program can run from the customer side, it may not work properly due to network connection or internet connection or lagging of resources. Even though the program is logically correct, it may terminate unexpectedly and exit abruptly due to the runtime issues or environment factors. The end user or customer not known what really happened. For example, a end user can copy a content from mobile phone to his laptop. The copying process can be executed by computer program. But if any small network issue, the connection may lost at that time. So the program can terminate suddenly. This is purely happened due to the runtime environment reasons. This runtime errors is called exception. So the program developer must handle this kind of runtime errors or exception. That handling mechanism is called exception handling. In a Python program, exception can be handled by means of these four blocks: try block, except block, else block, and finally block. The code, which may use the runtime resources, can be identify the programmer and that can be written in the try block. If the exception is occurred, the except block code will be run. If there is no exception, else block code will be run. Finally block is executed after the exception can be occurred or not. This code will run to clean up the operations. Let's conclude the definition of exception handling. A mechanism that allows developers to manage and respond to runtime errors or unexpected events that occur during the execution of the program. You must clear about the compile time error and runtime error. Compile time error only happened when we made the mistake in the syntax of the programming language. When we do the compile time error, your program cannot be executed. We can easily solve the compile time error. When the runtime error, the error can be happened during the execution of the program that may be differed from one end user from the another end user. So we cannot predict the exact runtime error. So it is very difficult to solve the runtime error compared to compile time error. The exception handling cannot resolve this runtime error. Rather than it indicates the reason for this runtime error. So the end user or customer aware of this error and to avoid this situation. This is the simple syntax for exception handling mechanism. Whatever the code or suspect to throw runtime errors that can be written inside the try block and the appropriate errors message can be present in this except block. And this is the one simple example program. In this example program, x value is assigned to 10. Let's imagine this value can be taken from the any network devices or external file. So when we read this file at the execution of the program, there is a possibility to receive this content. So the variable involved statement can be written inside the try block. If any issues to print this content, the except block can be executed. So in this example, the value is directly given. So when I execute this program, the value 10 can be printed. But when this value is not read by the external resources means the exception block can be executed. I will explain this concept in another example called division by zero exception. When an integer can divide by 0, we cannot get the exact value. Here, a value is 10. B value can be get from the user. The user can give any value. Suppose the user can give the value as 0, this division operation cannot be performed. So the exception can be happened in this code. So I can redefine this code in this format. The suspected area can be bring into the try block. If there is an exception, that means if b value is 0, so it clearly tells the reason for the exception. So in this way, you can write the exception handling program in Python. You can identify what are the problematic area in your code. That code should be present inside the try block. The corresponding exception can be handled inside the except block. When I execute this program, I can give the value 2. So 10 divided by 2 give the value 5.0. When the user give the value as 0, so in this input, this code cannot be executed. So except block can be executed, that is exception can occur. We can handle more than one exception in a single program. So in this try block, we can give the suspected code that may raise the runtime errors. The runtime errors may happen due to different reasons, that means different exceptions that can be handled from different exceptions like this. The best example is if you want to read a file from the external source, the runtime error may happen due to the operating system error or sometimes the file may not be present in the particular location. So the reason for raising the runtime error may be operating system or file may not be present in the particular location. So in that situation, we can throw two different exceptions like this. So Python program may also handling more than one exception in a single program. And you can also include the else block in the exception handling mechanism. Else block means if there is no exception occurred, this else block code will be executed. The syntax for this else block coding is inside the try we can give the code If there is an exception occurred, the except block will be executed. Otherwise, else block will be executed. Reason for the else block is it ensures that certain actions are performed only if no exceptions occur. It improves readability. It makes the code easier to understand by distinguishing successful operations from error handling. And we can also include the finally block inside the exception handling mechanism. The reason for using finally block is especially for performing cleaning operations, releasing resources, or ensuring consistent system behavior. This block can be executed either exception can be happened or not. Resources like file handles, network connections, or database connections need to properly closed or released. When we are using such kind of resources in the try block, that should be properly closed. Either exception can be happened or not. So finally block is necessary such kind of situations. It helps to maintain the program stability by executing important final steps such as logging events or resetting shared states. So this is the complete exception handling mechanism used in the Python program. You can write the suspected code here. When the runtime error happened, this block can be executed. Otherwise, else block can be executed. Whether except block or else block, for any cases, finally block can be executed. Let's see one example program. In this example, I can store the particular student mark in a list. There are 6 marks are there. I can read the user input to specify the particular position of the mark. If the value is 0, I can print the mark as 20. If the value is 5, I can print the mark is 94. So after reading the user input, I can assign the mark into the variable called n. If the n value is loaded properly, else block can be executed. Suppose if any problem for reading the n value, for example, the index values are start from 0 to 5. So the user can give the out of the index value means the mark cannot be assigned to the value n. In that situation, exception block can be executed. So the index out of bound message can be printed to the user. If the exception can be happened or not, finally block can be executed. So let's check this program when executing with different values. I can run this program. So I can give the index value, for example 1. So I want to read the second mark. So in this case there is no exception can be happened. So the value is printed and finally block is executed. I run the program again. I can give the index value 8. But the maximum index value is 5 only, 0 to 5. I can give the value out of the index range. Now the exception can be happened because there is no 8th index. So the exception block can be executed. That means index out of bound error message can be thrown and finally block is executed. This is the simple program. So we cannot include any database or any network connections. So we need not to use the finally block. So this code also run without the finally block. So the finally block is the optional block we can add when we are use the different resources in try block. These are the different inbuilt exceptions present in the Python program. We can include these exceptions whenever we necessary inside our program. Apart from these inbuilt exceptions, you can also include your own custom exceptions. In some situation, we can create our own exceptions. That is called custom exceptions. This is the syntax for creating custom exception, in which you can create a class called custom error, in which you can throw the any runtime error message, or you can type simply the pause keyword. In a Python, pause is a placeholder statement used when a statement is required but you don't want to execute any code. It does not perform any action, but it is syntactically correct. The pause allows you to create a custom exception class without adding any extra functionality. Let's see one example program. In this example, I can read one integer value. In my problem statement, that value must be a positive number. I want to check that number is less than 0 or not. If it is true, I can raise the custom error using the raise keyword. So I can create a class called custom error in which I can write some code. If I don't want any code means, for example, in a simple problem, I can simply write a statement called pause. So this is the statement available in a Python, but it does not perform any action. We can give the error message in the argument of exception. If there is no exception, that means if it is a positive value, the else block can be executed. I can execute this program. First I give the positive value 5. So this program is executed properly. Suppose if I give the negative value, for example -7, it throws the custom exception. So in the inbuilt exceptions, there are predefined exceptions are available. But in our program, we can identify some specific runtime error may happen during the execution of program. In that situation, we can create our own custom exceptions. Let's conclude what are the concepts we learned in exception handling. Compile time error and runtime error. Improper syntaxes may lead the compile time error. It is easy to resolve, but runtime error may happen only during the execution of the program at the customer side. We cannot predict the runtime error, but we have to handle this error to tell the reason for this runtime error. That concept is called exception handling. Exception handling cannot resolve this runtime error, but it tells the reason for the runtime error. When we are using the exception handling in your program, you can include try, except, else and finally block. So there are inbuilt exceptions are available in Python. Apart from that, we can also include our own exceptions called user-defined exception or custom exception. Let's conclude the topics we learned in this Python beginner video. We learned from the Python installation and simple programs and necessary concepts present in the Python programming. I hope this video helped you to familiarize about the Python program. In this description part, I gave the notes what are the topics we learned in this video. You can click and download it. Thank you for watching this Python beginner video. I hope you found it helpful and informative. If you have any questions or need further clarification, feel free to make a comment. Best of luck with your learning journey and all the best.